Hello. So till now we have finished this topic. First, overview of vector algebra, dot product, cross product and coordinate system. So till now we have finished two coordinate system, rectangular and cylindrical coordinate system. So now today we start third coordinate system, which is spherical coordinate system. So as the name, the spherical coordinate system is indicate the shape of the object is like as a sphere. So the spherical coordinate system is represented using r, theta and phi. Okay, in last lecture we study cylindrical coordinate system. So cylindrical coordinate system is represented using three variable rho, phi and z. What is rho? Rho is the radius of this circle that we have to see from the top side, so it is look like as a circle, so it's the radius of the circle. What is phi? Phi is the angle between the line which is passing through our desired point P with respect to x-axis, it is known as phi. And what is z? Z is the height of this cylinder, okay, from the xy plane. So now in today we discuss spherical coordinate system r, theta and phi. Okay, so the one variable is common. Which variable is common? Phi is common. Here it is also 5 and here it is also 5. So phi is common in both spherical coordinate system and in cylindrical coordinate system. And what is phi? Phi is the angle between the line which is passing through our desired point with respect to x-axis always. Okay, so it is known as phi. So here the phi is same. Okay, but what is r and theta? So here r is nothing but is a radius of the sphere. Okay, what is the sphere? Actually the shape of the sphere is like as a football. Okay, so I have to draw our reference coordinate system. Which one is our reference coordinate system? Always and always Cartesian coordinate system, or you can say that it's a rectangular coordinate system. Again I have to repeat, rectangular coordinate system is also known as the Cartesian coordinate system. Okay, now I have to draw a sphere. Sphere means it's a look like has a one type of football, and the center of that football is located at the origin. Okay, so center of the football is located at the origin. Okay, so I try to draw sphere. So this just look like as a sphere. Okay, and where is the center of the sphere? The center of the sphere is at the origin. Okay, it's not a square. Sorry, it's not a circle. Okay, actually it's okay. In a 2D view, it is look like as a circle. Okay, but in a 3D view, it is look like as a sphere. Okay, now what is r? R is the radius of the sphere. Okay, so we have to measure the value of r from the center point of our coordinate system. Okay, so as we know that suppose I have to take one football, okay, or I have to take one ball, okay, and I have to measure the distance. I have to measure the distance between the center point of the ball with respect to their peripheral. Okay, so actually it's a radius of this ball. Okay, so it remains same. Clear? So r is known as the radius of the sphere that we have to measure from the center point of view. Okay, you can take the example of earth. Okay, suppose if you measure the distance of any country, with respect to the center of the earth, it remains same. Suppose I have to measure the distance of our country with respect to the center of the earth, and I have to measure the distance of America or any other country with respect to the center of the earth, it remains same. The distance with respect to the center of the earth, it remains same. Okay, because it is ultimately it is known as the radius of the earth. Okay, so similarly this one is known as the radius of the sphere and it is known as r. Okay, so you have to just observe it is look like as a 3D. Okay, one type of football. Clear? Or it is a one type of cricket ball. Okay, now next thing is what is theta? So theta is the angle between the line which is passing through our desired point with respect to the z axis. It is known as theta. Okay, and what is phi? Phi is the angle between the line passing through our desired point with respect to the x-axis. It is known as phi. Okay, now most important thing is, suppose I have to cut my sphere from the different portion. Okay, suppose I have to cut my sphere from this side. Okay, I have to take one knife and I have to cut the sphere from this side. From the top side I have to cut it. I have to cut it from the bottom side also. Okay, now I have to cut it from the center side. Okay, so if first I have to cut my sphere, I have to cut my sphere from the top side, and if I have to look from the top side, so it is look like has a very small circle. Okay, next if I have to cut my sphere from the center side, and if I have to look from the top side, so it is look like has a very big circle. And what is the radius of this big circle? It is r. It is the same. Okay, because I have to cut a sphere into the two equal part. Okay, so whatever the circle we have to observe here, the radius of the circle is r. Okay, but for this circle the radius is not r. Similarly, for this circle the radius is not r. Clear? Okay, so if I have to cut the sphere into the two equal part, okay, so the radius of the circle that we have to observe from the top side, it is r. Clear? Now theta. So theta is the angle that we have measured. Theta is the angle that we have measured between the line passing through the point with respect to the z-axis. Okay, so just I have to take one example so you can get easily idea about it. My point is something here. Okay, I will take this example. Okay, then after we have to take one point. Okay, just suppose assume this one is the location of my point on the sphere. This point is present on this surface of the sphere, not inside the sphere. It is present on the surface on the sphere. Okay, so now what is the distance of this point with respect to the origin? The first question, what is the distance of this point with respect to origin? It is r, because it is a radius. Okay, so wherever the point is located, okay, this point is located anywhere on the surface of the sphere, this distance remains same. It is r. Okay, clear? Suppose one person, okay, suppose today one person is standing in city A, and I have to measure a distance of that person with respect to the center of the earth. Okay, and then after the same person in second day, okay, is standing in another city, and I have to measure the distance of those person with respect to the center of the earth. It remains same, because ultimately the person cover the distance on the surface of the sphere or the surface on the earth. Okay, so the distance of that person with respect to the center of the earth remains same. It never change. Okay, so suppose this point is located anywhere on the surface of the sphere. I have to repeat, on the surface of the sphere, the distance of this point with respect to the origin, it remains same. It is r. It is known as a radius r. Okay, next, what is theta? So here theta is the angle that we have measured with respect to z-axis. It is known as theta. Okay, so this angle is known as, which angle? Is a theta angle. Okay, so this angle is known as theta angle. Okay, so theta is the angle that I have to measure with respect to the z-axis. Okay, so this angle is theta. Now my question is, suppose the point P is located on the z-axis. Okay, listen, my question is, suppose point P is located on the z-axis. So what is the value of this angle? Angle theta is 0. Okay, and point P is located on the y-axis. So what is the value of this angle theta? Theta is 90 degree. Similarly, point P is located on the x-axis. So what is the value of this angle theta? Theta is also 90 degree. Clear? Okay, you can assume in a 3D view. Okay, so you can get the clear-cut idea about it. Okay, now next is what is phi? So phi is the angle that we have measured with respect to the x-axis. Okay, so what we have to do? I have to just take one center point and I have to draw one line which is parallel to the x-axis. This line is parallel to my x-axis. Okay, and one more line which is passing through the point P. Okay, and now I have to measure angle. Okay, so this angle is known as angle phi. Okay, or what I have to do? I have to just draw a shadow of this point. I have to draw a one shadow of the point. So suppose the shadow of the point is something here, for example. Okay, the shadow of the point is something here on the xy plane. Okay, and what I have to do? I have to do the same thing. I have to draw one line which is passing through this point. Okay, and I have to measure angle with respect to this point x, and this line, it is known as phi. Okay, so these two value of phi are same. Okay, so if I have to look from the top side, okay, if I have to look this figure from the top side, okay, so these two line both are intersect, these two line both are intersect. Okay, this P is the original point, but this P is a shadow of this point. Okay, phi and phi both are same. Clear? Okay, so actually this one is my spherical coordinate system. So what is R? R is the radius of the sphere. Okay, so if point is present anywhere on the surface of the sphere, R remains same. Okay, and always point is present on the sphere, not inside the sphere. Okay, what is theta? Theta is the angle that we have measured with respect to the z-axis. And what is phi? As we know that phi is the angle between the line which is passing through point P with respect to the x-axis. Okay, it is known as phi. Clear? So now I have to just take one example. Okay, so you can get the clear-cut idea about the spherical coordinate system. Okay, so let us take the example. So suppose point P, value of point P is 4, then after 30 degree, okay, and 60 degree. Okay, so here what is 4? 4 is radius of the sphere, 30 degrees theta angle, and 60 degrees my phi. Okay, now what I have to do? First I have to just draw a spherical coordinate system. First I have to draw a x, y, z axis. Okay, then after I have to draw a sphere, and now I have to adjust the radius of sphere is 4. So I have to draw a sphere in such a way that the radius of this sphere is 4. So what is the radius of the sphere? It is 4. Radius of this sphere is 4. Okay, now next is theta. Okay, so suppose I have to point my point here. Okay, so for example, the point is present here. This one is my point P. Okay, so this one is R. Okay, this one is R, it's a radius, and it is 4. Okay, and 30 degree angle theta is 30 degree with respect to z axis. Okay, so this one is my theta. Okay, and phi 60 degree. So how to draw this angle phi? So I have to draw one line which is parallel to the x-axis and one more line which is passing through my point P. Okay, and whatever the angle is present between these two lines, it is known as angle phi. Okay, and now what I have to do? I have to just draw a shadow of this point. Okay, I have to just draw one shadow of this point. So this one is the shadow of the point. So P is nothing but the shadow of the point. Now to draw one line which is passing through the origin to the shadow of the point. Okay, and again whatever the angle we find, it is the same angle, it is known as phi angle. Okay, so this r, theta and phi. Now as we discussed earlier, if I have to cut my sphere from the center and if I have to look from the top side, okay, so I have observed one circle, and what is the radius of this big circle? The radius of the circle is small r, because I have to cut a sphere from the center side. Okay, but if I have to cut the sphere from the top side, okay, so the radius of this small circle is less than r, and what should be the value of those radius is, okay, so this radius is important for us now. Okay, so here, okay, so we have to say that the radius of this circle is nothing but, we have to say that is a rho. Okay, so we have to actually interested in this circle only. Okay, this circle. So what is the radius of this circle? The radius of this circle is rho. Okay, and what about this one? What about this circle? This circle is the biggest circle because I have to cut the sphere from the center side. Okay, so its radius is r, but for this circle the radius is rho, which is less than r. Okay, now see here, you can say that this distance is r. Okay, so this distance is rho from the center to the point P, it is rho. Now this P is also a shadow of my point P, so this one is also rho. Clear? I just apply the trigonometric concept. Okay, and which one is the height? Height is z. Okay, so it is known as height from the xy plane. This one is the height of my point. Okay, so this also a z. Okay, so now you can observe this figure in a 3D view very easily. Okay, so now you can get the clear-cut idea about all those things. Okay, so actually it's a one rectangle. If you observe, it's a one type of the rectangle. Okay, this two side, okay, this two side length is there and this two side length is rho. Clear? And r. Okay, so actually it is look like in this way. Okay, I have to draw in a 2D view so you can get the easy idea about it. Okay, this length is rho, this, okay, this one rho, this one is also rho. Now what about height? Okay, z height, so this one is my height z, this one is also a z height. Okay, so this one is z. Okay, here it is origin, and this one is my r, it is r. And where is my point P? My point P is present something here. This one is the location of my point P. Okay, and this one is angle theta. Clear? So now it's very easy to apply the trigonometric concept. Okay, what we have to do now, our next topic is relationship between spherical coordinate system with Cartesian coordinate system. Okay, so now you can just apply your trigonometric concept. Okay, so what is r? I have to just write the equation. What is r here? R is equals to under root of rho square plus z square. R is equals to under root of rho square plus z square. Okay, clear? But now the question is, what is rho? So rho is the radius of this small circle. Okay, and if you notice here, it is a rho. So now I have to draw this one, or you can apply the same concept that we have applied in our cylindrical coordinate system. So in cylindrical coordinate system, what is rho? In cylindrical coordinate system, the rho is under root of x square plus y square. Okay, so you can say that this rho is nothing but rho square is equals to x square plus y square plus this z square. So what is r? R is under root of x square plus y square plus z square. Clear? Okay. Next one is cos theta. What is cos theta in this case? The cos theta is equals to z by r. Cos theta is equals to z divided by r. Okay. Sin theta is equals to rho by r. Okay, you can write sin theta is equals to rho by r. Okay, and what is tan theta? Tan theta is equals to rho by z. Tan theta is equals to rho by z. Okay, so now based on all those equations, now you can derive the relationship between spherical coordinate system and Cartesian coordinate system. Okay, so now I have to just write the equation of first Cartesian coordinate system in terms of spherical coordinate system. Okay, so here it is, sin theta is equals to rho by r. So and what is rho? So from this equation, okay, from the cylindrical coordinate system equation, x is equals to rho cos phi. So what is rho? Rho is equals to x by cos phi. Okay, you can say in this way. So instead of rho, you can write is a x by cos phi or y by cos phi. Okay, you can write anything. Okay, so here rho is equals to x by cos phi or rho is equals to y by sin phi. I have to write these two equations from this cylindrical coordinate system. Okay, why? Because here this one is also a rho. Okay, so if we have to apply the same trigonometric for this circle, we will get this equation. Okay, so I have to just put those value here in this equation. So first of all, put rho is equals to x by cos phi. Put here rho is equals to x by cos phi. Okay, so what is x? X is equals to r cos phi sin theta. Okay, next put rho is equals to y by sin phi. Okay, so y is equals to r sin phi sin theta. Okay, this one is theta. Okay, and what is z? Z is equals to, okay, from this equation z is equals to r cos theta. Okay, so you can derive the equation of Cartesian coordinate system in terms of the spherical coordinate system. It's very easy. Okay, now we have to derive the equation of spherical coordinate system in terms of Cartesian coordinate system. Clear? So now r, what is r? We have already derived. R is equals to, under in terms of Cartesian coordinate system, it is under root x square plus y square plus z square. Next, theta. What is theta? So from this equation, theta is equals to rho by z. You can write theta is equals to rho by z. Okay, theta is equals to tan inverse rho by z. But rho is a variable for cylindrical coordinate system, so you cannot write in this way. So you can write, okay, so how to pick up this equation? You can write theta is equals to z by r. Okay, and what is r? R is equals to under root of x square plus y square plus z square. Okay, so theta is equals to cos inverse z divided by under root of x square plus y square plus z square. Okay, or you can write cos inverse z divided by r. I have to write from this equation. Okay, and last 5. Okay, so this 5 is the same as a cylindrical coordinate system, which is tan inverse y by x. Okay, so 5 is equals to tan inverse y by x. Okay, so I have to derive relationship between cylindrical coordinate system with I have to derive the relationship between spherical coordinate system with Cartesian coordinate system. Okay, so it's very easy. So what we have done in today's lecture, in today's lecture we discuss about the spherical coordinate system. Okay, so now we have completed this topic, overview of vector algebra, dot product, cross product, coordinate system. First is Cartesian coordinate system, second cylindrical, and third is spherical coordinate system. Okay, so in next lecture we will discuss about how to convert a point and vector from one coordinate to the another coordinate system. Thank you.